Welcome, and I talk about visualizing microservices. I'm going to talk about a story of managerial fears and analysis paralysis. It's an expensive title, but there are not that many people here, so if you have a question or a remark, interrupt me, and we can talk about it. I'm Andreas Evers. I'm from Belgium, and I work for a company called Ordina, where we do consulting. And lately, a lot about microservices at many of our clients. And there we've seen some pros and cons to microservices. The way you have to manage microservices, that's interesting as well. I'll be talking about that a little bit. But to start the story, we have to go back to where it all began, which is at Monolith. The organization asked me to put some Game of Thrones inside the presentation, so I guess you'll see a little bit more of that. So monoliths, who's still working on a monolith? It's 2 people. And who's working on microservices? Okay, almost everyone. Okay, actually I'm going to give a little introduction to why microservices are good, so maybe it's not really new for you guys. I'll try to skip it fast. So basically the monolith has some downsides to them. And it looks a bit like this. This is the adapter pattern, so it's still a nicely structured monolith, but still, with monoliths, the problem is that you have the lead times are very long. So when you want to go from an idea to basically delivering it as a product, you sometimes have months, sometimes years. And then the thing is, when you actually delivered it, it doesn't really make sense anymore, right? So it's often the problem of feedback loops between business and development. You want to keep that as short as possible. And basically with a monolith, that's pretty hard to do. Because basically you also have the issue of the butterfly effect. Everybody probably saw that movie, but in software it's a bit like that if you have a monolith. You change one thing and you basically change everything. You don't know what you caused with your little change. And you kind of have to test everything. So you kind of have to have an army of manual testers who have to test every release cycle, everything again and again. And that's not really, it doesn't really lend itself for agility. So there's also the thing of scaling. With monolithic applications, you have an application server. And with application servers, the problem is that you have to go through other teams to get them provisioned, unless you work in a DevOps organization, which is a lot better, but mostly in the companies I've seen using monoliths, they also have separate technical teams, network team, operation system team. Then they also have an application server team. So if you want to have an extra application server, you got to plan up front. Right? And that's possible if you plan, for instance, for Christmas, and you know there's going to be a peak in traffic. Christmas is coming, lots of sales, right? But what if your company is all of a sudden in the news, right? Then you might have a lot of extra traffic, and you really can't scale out that quickly, right? So heavy load in general is difficult, but if it's in a single component, it would be easy. It would be nice to have the possibility to upgrade or upscale that one single component. In a microservice architecture, that's possible, but in a monolithic application, it's a lot more difficult to do. So we start looking at these applications as monolith monsters, right? They're very scary for us as developers, but basically for business as well, because it's a lot of downsides to them. And if you want to have a competitive advantage, then a monolith really doesn't really help that much. So the community has been looking to other solutions, other architectures, and microservices, as you will probably know, is one of them. We are also in the microservices room. So it really shows that it's more than just a hype. So the original picture from before is now looking a lot different. There are more modules, and they're very explicitly defined. And between these modules, there's network. Right? That's the main difference. They are defined around functional boundaries, which are bounded contexts, as in DDD. And that helps us to focus a lot more. So there's some pros to this architecture, but as with every architecture, there's no such thing as a free lunch. You always have to give trade-offs. You have to make trade-offs, and there are some cons as well. But with the pros, you have these strong module boundaries, right, which allow you to have small teams and put these teams independent of other teams. So it also lends itself for working remotely if you at least put your teams together. the people inside the team together. So strong module boundaries with the bounded contexts that you have to define. Independent deployments, you can really just take one change in one component, and because the boundaries are defined that well, you don't have to redeploy everything. You don't have the cascading changes that you have to make. Technology diversity is something for developers, super interesting, right? Who is actually a developer here? Okay, so that's probably why we like this architecture, because we can adopt new technologies really quickly. If there's something new, also for business, this is interesting because if a new technology really gives you business value, often in the monolithic application, it's very difficult to introduce this because you probably, if you want to change the underlying framework, then you have to rewrite the entire application. If you use microservices, that's much easier to do. So technology diversity is awesome. Security segmentation, that's for financial sector, something interesting. For instance, you have accounting microservice. On that one, you want a lot of security, right? Because that has something to do with your transactions and your financial entities. But if you have a marketing side to your organization, you can have a marketing microservice. There's no reason to put really that much security on there as well. And with a monolithic application, you kind of have to do it everywhere, right? So with microservices, it allows you to be more, to add more simplicity to the components where simplicity is allowed. That's beneficial as well. Separate scale out, so the problem with the monolith is now no longer there. You can scale up the microservices that you think need more traffic. You can also have elastic scaling as well. Because you work with 12-factor apps, if you're familiar with that, which also allow you to have stateless applications, so you kind of have an easier time to scale up. And then parallel development. So these teams are focused on single functionalities, on a single scope of a bounded context, so they don't have to worry too much about how the entire system works. They just focus on their own scope, allows them to work faster, parallel to other teams. Okay. So pros, great. You probably already knew this, right? But the cons, which are even more important, I would say, the big con is distribution. So the first rule of distributed architecture is don't do distributed architecture, right? It's very difficult. Try to avoid it. However, if you want to have all these advantages, then you kind of have to go there, right? And with distribution, you add a lot of complexity because all these floating components can go down at any moment, right? So you gotta have failover, you gotta have resiliency put in place. You really gotta think about that up front. You gotta think about circuit breakers, bulkheads, that kind of stuff. Event consistency is something to think about. So before we had just one database, which was awesome, right? One database, one data, one place for the data, and you had foreign keys everywhere. Great. But with microservices, you want to split that data. You want to put them in different databases. You can do polyglot persistence if you like, but then you have basically no foreign keys anymore. So you have this inconsistency. So if you really want to have that, you got to go to distributed transactions. But nobody really wants to go there because it's a road where you don't want to end up with. So without distributed transactions, the only thing you're left with is eventual consistency. You just accept that your data is not going to be consistent. And basically, that's not so bad, basically, because people kind of, analysts and business and managers often want to push real time, that everything has to be real time, right? So they think of a new functionality and they think, yeah, this really should be real time. But if you think about a website, if you load the website, the moment it's on your screen, it's already eventual consistent. It's already out of date, right? So a lot of these scenarios are just capable of being eventual consistent. You just don't have to be real time at all times, okay? Except if you, for instance, shows stock real time, stock data or something, then you could use WebSockets and that kind of stuff. That really is real time. But a lot of the other stuff lends itself to be eventual consistent. But it's still something to really think about. And then operational complexity. It's the big one as well. So you got to think about how to monitor, how to make things visual in your architecture. And that's something where there's already a lot of effort being done in the microservice community, but there's still some things that are lacking for visibility. Operational-wise, you can have metrics, you can have log aggregation, that kind of stuff. But for a functional standpoint, functional point of view, that's often a point where we don't have any tools available. Okay, so as you can see here, you have pros and cons. So it's like what Simon Brown says. Watch out, don't go to microservices. If you can't build a monolith, what makes you think microservices are the answer? So you first got to be able to build monoliths, then microservices, right? And it's about these principles, right? Development principles, ways of working with each other, right? For instance, a DevOps mentality has to be in place for microservices. And there's so many pitfalls that you really have to constantly remind yourself of the implications of choosing for microservices. And for instance, there's this thing, the technology diversity makes people very happy, developers very happy. They really think like they're like space cowboys or Daenerys Targaryen riding on the dragon, right? Because they can use any tool that they want, any framework, any language now inside their microservice. Yes, question? In what sense? Yeah, okay. So the question is, if so if you want to go to microservices, you already have to be able to build it or to architect it. I think it's a bit of both, because if you start building your microservices and you don't have the skills to build the monolith, I mean, really build it. I mean, your architecture can be fine, but if people start taking shortcuts on the contracts and on all the different, like circuit breakers, for instance, they don't tune them or they don't implement them at all. These things are a lot about discipline. And that's mostly the thing that also went wrong with monoliths, discipline. And architecture of a monolith can still be fine, like the adapter pattern, which I've shown. But people find it much harder to keep that discipline in place. Like, for instance, the broken window idea, where you have a building, your monolith. Yeah. So basically, it's also the building, I would say. Yeah. Okay. So yeah, these developers, they feel like cowboys, right? They can do whatever. So managers and architects, on the other hand, they look north and they see the white walkers, right? Because their whole architecture and their whole IT organization is now a land of the free, right? Everybody can do whatever they want. So if you have the best engineers in the world, fine, you can give them all this responsibility. But if they are not like if they don't have that discipline, then basically it's very scary, basically. So basically, what I'm going to talk about now is a couple of stakeholders in the organization that have worries and that have concerns about going to microservices. We see that in a lot of the companies where we implement microservices, that these people have such fears, right? And those are the people that also count, because developers themselves, they're very happy with this architecture, but managers, for instance, have to pay for it, right? And analysts have to be able to predict things. So the first category of people, and I hope there's no one of them in the room, is managers. Any managers? Okay, sorry. No problem. So managers also need to be heard in this architectural choice. They want to like to have a grip on things, right? So as a manager, you want to get a sense of compliancy and maturity of your ecosystem. And in theory, it's nice to give freedom to your developers. But in practice, we see that in a microservice architecture, often the managers and architects, they want to impose a set of choices that the developers can choose between. For instance, you can choose between Java or JavaScript for your microservice, but don't do any other languages, because we don't have the people. Or you have to think about knowledge transfer and recruitment. Those things are important as well. So it's also possible to impose a set of rules that the teams have to abide by, or goals they have to achieve. For instance, that you have to have a quality gate in place, and your technical debt has to be less than 5 days, that kind of stuff. So those things are important to get straight. And then the contract is also very important. So aside from your technical implementation inside your microservice, it's maybe even more crucial to make sure that your contract between the microservices is respected. It should be according to an architectural vision and the standard across the entire organization. And that's something that needs to be visualized. Because you need to have, as a manager, the ability to track these things. You need to see that compliancy assurances and quality regulations are really respected. And it's basically a key enabler for managers to push for excellence and to go after the teams that need to be chased. But if you, as a manager, don't see anywhere where the lack of maturity is in your ecosystem, then it's a very hard job for you to judge whether there is actual work necessary. And for a developer or for an architect, that's very frustrating. But if you have a means to visualize this information, then managers will be able to give you the budget and give you the priorities as well to work on this. Otherwise, they're just going to work against you because they think everything is fine. We've seen this at many of our clients, and that's a real issue, because managers should be on your side in this story. And then, change management, something I almost forgot. So aside from the maturity and the compliancy, managers also want to see what's coming up, right? So change management is a very important aspect, and oftentimes we see that there's a ticketing system where you have to create a ticket for your release, you have to document it. But with a DevOps mindset, basically every team has its own release schedule, its own pace, and they go to production a lot faster. So having this ticketing system in place really doesn't work. Okay, so change management is more like a read model instead of a push model. So if you have a dashboard in place for changes that basically shows you what's currently there and what's coming up, then that already goes a long way in providing this information. Because if you go to microservices, you really have to think about all this as well, because culture is as important as the technical side. Okay, so the second category is analysts. Any analysts in the room? Functional analysts, business analysts? Okay, great. This might be a compliment or not, I don't know. Very smart guy. So analysts, they also want to see what's coming up and what's currently there. Right? They want to avoid duplication because they have to think about functional requirements and put them into documents or in stories or whatever. So they really need to see what's currently in the landscape, in the functional landscape available, and they need to see which resources are exposed by what microservices and which events are being sent back and forth between microservices and queue and so on. Okay, so that's an important thing. Also, can be solved by visualizing the architecture again. So visualization is again here very important. And then also impact analysis. If you think about a new feature, you want to implement that, then basically you want to see which services will be impacted. If you have microservices calling other microservices and you make a contract change, you want to make sure that these clients are aware of this. And this is really crucial to avoid breaking changes, and that often happens due to negligence. So having a dashboard which you can actually see what's currently there and what's coming up allows you to visualize this. Also across teams, if somebody is working on a certain functionality, then someone in another country might be working on similar functionality, but you don't know about each other, and you'll be duplicating code. Okay. And then aside from seeing what's currently there and seeing what's coming up, just like managers want to see, you also have the extra benefit of, or the extra need of impacting what will be coming up and defining this. So if you could put that in a dashboard as well or in a visual state to see with a timeline what's coming up later on, then that also helps you to basically avoid all these downsides or these issues with duplication and clients breaking and that kind of stuff. Okay, so that's analysts. Okay, and then the last category is developers. That's us, right? The grunts. you really have to get things done, right? So developers in microservice architecture, they're much more in a DevOps cultural mindset. So they have the responsibility not only build, but also run the services. So they basically want to see what's there, which dependencies your microservice has, and also which versions they have. So from a deployment point of view, that's also interesting to see these links. Okay, so it can also act as a hub, dashboard, to visualize how your architecture looks like, but also to integrate with, for instance, service registries or API documentation, or maybe performance tooling, or even reactive insights, which is an interesting one, which I'll talk about in a moment. Okay, so as you can see here, we have a couple of stakeholders in the organization, and mostly we're focusing on the development effort and making sure that our operational aspect is taken care of. But if we forget about managers, we forget about analysts, we forget about the entire ecosystem around your IT, then you're basically going to run into problems pretty quickly. Okay, so what did we do? We saw this at our clients as well, and we kind of tried to build such a dashboard. It kind of, I mean, I want to give you an impression of what it could look like if you would build something like that, but you can also reuse this because it's open source. So a microservice architecture can still be seen in layers, and how we saw it was we want to split the front end from the contracts and then the microservices themselves with the backends. Backends which could be data sources or maybe systems, third-party systems, or systems you can't change, like an existing ESB, for instance. So this is basically what we came up with. So here you can see the UI components, which could be, in our case, Angular components. The resources, they can be events or they can be RESTful resources, and the microservices with their bounded context, of course. So if you want to set this up, that's really simple. There's documentation, of course, on GitHub, but it's just a Spring Boot application with a starter. So I think who has actually worked with Spring Boot? Okay, that's a lot of people. So you just add a dependency to your POM file or to your Gradle build. Then you add an annotation, and you just run it with the Spring Boot Maven plugin. Okay, and that should work, should set up the entire dashboard for you. So, but often this is maybe even hard. I mean, not that easy for people who are not familiar with Java. This is JavaDay, so I assume everybody knows this. But you can just clone the repository as well, and you can run it from there as well. So there are some samples in there where you can start from, and with some mock data as well, which I will demo. So how does this look like behind the covers, right? So this is my architectural drawing for the application. We have a UI front end, which talks over HTTP with a server component. And the server component, the interesting part here is that it has these aggregators. And the aggregators are like sentinels that go into your ecosystem, and they try to figure out information about your microservices, the dependencies between them, and the contracts. So we have already 4 of these aggregators, but the idea is that they are it's auto configuration from Spring Boot, so it's super simple to override this or to write your own. And we already have a couple of them. So the health aggregator. So Spring Boot, it's a bit like Drop Wizard. They have this actuator feature where some of the functionality or metrics or beans or, I mean, a lot of information is being exposed over HTTP in a JSON format. Okay, so you can just call that and retrieve a lot of information about your microservice. And that's super simple to set up. So we query this, of course, using the service registry. And we support all the service registries from Spring Cloud. And we're going to add some of our own as well. And then we can get information about the state of the microservice, but also whether it's up, whether it connects to databases, whether it has dependencies on anything really that has a health indicator. And from there, we can also get information about that component, whether that component is up or not. So great source for pulling this information. And a lot of the dashboards out there, they don't really get this, they don't map to this granularity level. Okay, so they can see, for instance, that your application is up, but they won't be able to see that there's more information available on the health endpoint, for instance, about links that that this microservice has, which is, of course, very interesting for our dashboard because we show links between microservices and other components. So then we have the mappings aggregator. Mappings is also an actuator endpoint, basically, and it shows RESTful resources that are exposed on endpoints. And that's also interesting for our dashboard because then we can visualize the endpoints that a microservice exposes, and then we can integrate that with our UI components or with other microservices that call these endpoints. So a lot of information already provided by Spring Boot, and thanks Spring Boot. Thanks Stefan, who's in the room, for exposing this, because that makes our life easy for actually visualizing it. Then we have the index aggregator. Index is basically the concept of hypermedia. And is anyone aware of a hypermedia? Okay, great guys. So the idea of resources linking to other resources. It's a bit like on the World Wide Web where you have HTML pages which are also resources, and they have links, hyperlinks, and they link to other resources which are other pages. So in that sense, we don't have to bookmark every single page that we want to visit in the entire World Wide Web. We just have to know the root pages. And in an API, you can do the same thing. You can basically have a root resource, or an index resource in this case, which just shows links to all the resources that the microservice exposes. Great information for visualizing this as well. So if your microservice implements hypermedia or HTOS, then you can have this index endpoint which shows you which resources are exposed, which links they have, and we can show that in the microservice as well, in the dashboard as well, sorry. And then we have PACT. PACT is consumer-driven contract testing. Who is aware of that? Okay, that's almost no one. Consumer-driven contract testing is interesting because it's a safety net for your microservices. Basically, what it does is it allows your consumer to write a definition of what it needs from the producer. Okay, so if a microservice as a client calls another microservice as a server, you can say as a client, I want to call you, and I want to access this API, and I want to have, out of the 10 fields, I want to have the 2 first fields. Okay, that's what I consume. And make sure that you never change those, except ask me first. Okay, so that's the way that consumers document that. And what the producer does, it takes all these definitions and it runs tests against them. So in that sense, it can be very interesting to see that while you have changed something in your code on the producer side, you're breaking some of your clients because you changed those 2 first fields. Okay, if you have a test that validates this, that's very, very interesting, right? So that's a benefit for the consumer, but it's also a benefit for the producer, because if it has a catalog of who actually calls this API and who calls what of the API, it can see that, for instance, only the first 5 fields are used in general, and the last 5 fields are never used by anyone. So it doesn't even have to version to go to a next to change something in these 5 fields. It can just remove them or change them. And it's not backwards compatibility breaking. Okay, so that's for the producer also a benefit. So these contracts, these definitions are put into a repository with PACT at least, and we can query this. And this gives us great information about what communication lines are available and which ones are out there. And that's a good source for the dashboard. Okay, and there's something about consumer-driven contract testing. This is an implementation by PACT. PACT is the most famous one, I would say. It's available in a lot of languages. But there's now one from Spring Cloud as well. It's called Spring Cloud Config. Contract, sorry. That's something else. So Spring Cloud Contract basically has the same approach, but it's an implementation by the Spring guys. Okay, so we will integrate with that pretty quickly as well. So as you can see here, there's a lot of hooks, a lot of sentinels that we have for sensing how the ecosystem is connected, and it's an important part to our architecture. How did we build this? Well, on the server side, we used Spring Boot. It's Spring Boot auto-configurator, so you can just add it as a dependency and it will do its magic. And then you have Spring Cloud for hooking up to the service registry. Netty and RX Java, which we will also look into moving this to Reactor, Project Reactor from Spring as well, because that supports Java 8, and we're working with Java 8 anyway. But the idea is basically, if you have all these hooks that go into the ecosystem, you will have a lot of latency. And if you have a lot of latency, you have to optimize your application for that. Otherwise, you'll become very slow. So you have to make sure that you have the most optimized use of resources of your system. And that's what RX Java does. Okay? So if you are interested in this, just go to the project on GitHub and have a look. On the front-end side, we have D3.js, we have Angular, we have RxJS and TypeScript. The Angular 2 transition is almost complete, so we're also looking into that. And there is also the graph is being built by D3.js, and we're trying to have a reactive end-to-end flow. So now it's still in progress, and there's some blocking here and there, but we want to really have complete reactive with back pressure. Okay, so this is how it looks like. So what can you do? You can filter, obviously, and have a concise view of your specific application. So your specific microservice might be about pizza. I'll demo this in the next 5 minutes as well. And then you can see compliancy issues. So I was talking about managers who want to see compliancy, who want to see which microservices still have some work to do. And here, for instance, we have a microservice agenda, which didn't really expose any index. And on the context root agenda, we basically just query the index. Okay, so you see it's a 500. There's a server error. It's not really working as expected. And that's interesting because you might have clients bookmarking URIs of other resources, but if the index doesn't work, they're probably also not implementing hypermedia. And obviously, the server side, the microservice itself, has some work to do. So as a manager, if you can see this in a dashboard, you can see, okay, the agenda, okay, I can make the link is by the agenda team. They have to do some work. Okay, so I can chase them. Then we can also add nodes, and that's the idea for analysts. They want to impact what's coming up. They want to define that. And you can easily just create a new front-end node or contract node, microservice node, or backend node, and you can link them up to existing nodes. Once the microservice or whatever item you have built is finished, it will actually end up in the dashboard as a real node, and the virtual status will disappear. So this can also give you a view of virtual states of the next months or years, and make sure that if you started building something, that another team doesn't have to start on the same thing that they first ask you because they see it in the dashboard. Okay, so this stuff it's out there. It's documented, obviously, on GitHub as well. I'll just give you a quick demo. 1 second to change the displays. Okay. So if you go to the GitHub, you can, well, go to the server side. Okay, so you just clone this repository. Is this readable? Or is it better? Okay. So you just clone the repository, pretty simple. Once that's done, you can already go to the samples if you want to run a sample. So samples, and there are 2 samples right now, which is the simple mocks and the simple version. Simple version is basically just a naked version, which gets you up and running. But the mocks one is the most interesting one because it visualizes the stuff I have screenshots of. And here you can do Maven. If you don't even have Maven installed, you can use a Maven wrapper, which also comes from the Spring Boot application. So Maven Spring Boot run, that's the Spring Boot Maven plugin. And it will just build the project, and then it will run the project. So it's super easy, normally. So in this way of working, I don't even need to know Java. I don't even need to know Maven. Okay. So then I can go to localhost, and my dashboard should appear. Okay, great. So now we can start filtering, and we can see a subset of all the data. So what we can see here now is I have a pizza application that that has a UI, but if there's an issue on the UI, what do we normally do? We really want to figure out, okay, which data could be the problem. If there's a problem, not just in the application, but in the microservice or in the backend. So now we can have a full trace of for troubleshooting of where a problem might occur. Okay, so this is probably pretty beneficial. Then we can also add a resource, or we can add a microservice. Can do it here. So I can do a JavaDay resource, or microservice in this case. I can link it up to loyalty detail or to maybe employee. Let's higher up the list. Then submit it. You can also enter information about the release date or whatever project code that you might be using. And you can see it's a green line, so because it's virtual, so we can sort JavaDay, and JavaDay is now connected to your employee backend. So here you can add any node on any level and hook them up. Okay, and once they become available in the ecosystem, they will be replaced with real nodes. Okay, so that's pretty straightforward. And we can also see that there's issues. Like here we can, for instance, see the microservices, they have 0 issues, except for user preferences. I think that's about the only one. And this one also has the issue with the index that's not able to be fetched. So if any of the aggregators face an issue, you will see them they will see them collected in this overview. Okay, so you can also change to any microservice. So for a manager, it's very, very easy to see that you have all these microservices, and right now they're all in good shape. But once they are not compliant to some regulations that you put in here, then you might start seeing issues, and that's for a manager super interesting. Okay, so we also have integration coming up with Spring Boot Admin, and Spring Boot Admin, have you seen it lately? It's pretty cool. So basically, it looks like this. And it looks a bit like the Spring website, a bit like our application. So integration is very straightforward. And it shows you the details of the microservices themselves. It reads these actuator endpoints from Spring Boot, and it visualizes all the details. It doesn't just use them for the dashboards, which we are using them for, but it shows them in a detailed overview, which is nicer than just having JSON to look at, right? So here you can see also how it normally looks like. And a new interesting feature that they've built in is that it now integrates with, well, you have logging, so your log files are exposed, but also we have, we can set log levels as well, and they have historics automatically integrated in the dashboard, which is pretty cool, right? You don't even have to run your own historics dashboard. So having integration with this is coming up, and we're also going to integrate with other frameworks, or other tools at least. So if you just switch back real quick. So we have the Spring Boot Admin dashboard. We're also going to integrate with Zipkin. So Zipkin is also, Spring Cloud also uses Zipkin for distributed tracing. Zipkin is, by the way, from Twitter, and Sleuth from Spring Cloud provides a stream of information for that dashboard. Lagom, which is a bit like Spring Boot, but from Lightband, they also talked to us and asked us if we could integrate their services as well, so we're looking into that. And then we have Project Reactor. The interesting thing about this is that with reactive streams, it's often unclear where certain traffic is going through, or what's happening with your data within your microservice. But not only within it, but also through, to other services. And the back pressure idea is really useful to be visualized. So we've been talking to Stefan Naldini a lot about this, and there's already some efforts to look into how we can also visualize that traffic in a reactive nature. And then Kubernetes is something where we want to have a service discovery integration with as well. So that's coming up. Okay, so I don't know if I still have a lot of time. So just to come back to our story, we started out with a monolith, and then we moved towards, Then we moved towards microservices. Why do we do this? Because there are some Silicon Valley companies and high-performing IT organizations that manage to deploy 30 times more frequently than regular companies, 200 times shorter leads, and when they basically go to production, they do that with 60 times fewer failures. And when they have failures, they recover 168 times faster. I mean, if you have to compete with that kind of organizations, then you can already start worrying a little bit, right? So microservices is really giving you that competing edge to go faster, to be agile, but it does come with some concerns, and not just from operations, not just from developers, also from managers and analysts. And that's something we have to take into account and start building solutions for. The dashboard which we've built is helping in that sense, but we're really looking towards the community as well to give input on what's really important, what are people missing when they are transitioning from a traditional model towards a very DevOps lean way of working with microservices. So in that sense, we want to kind of move away from the safe haven of monoliths to a new microservice way of working, visualize that, and ask you guys for feedback. Okay, so if you guys think of something that could be integrated here, please also open issues on the GitHub projects or reach us on Twitter, because basically it's not a one-man effort. This is an entire team that was behind this, and a lot of contributions as well. I mean, that's really what makes this thing useful. Okay. So basically, if you have any suggestions or feedback or questions, you can ask me now, or you can reach me at Andreas Evers, or you can go to the project page and give any suggestions or remarks. So I think that wraps up the talk. So if you guys have any questions, feel free. Yes.
Thank you for your speech. I think I can go without the microphone. Probably for the record one. Okay, my question is more exactly in this DevOps direction. So does this dashboard has any kind of integration with such tools? I mean, real operational world tools like New Relic, like Insignia or Nagios, some kind of such stuff. So configuring this visualizer for your services that has some outages or changes or whatever gives you integration with the tools to which the usual DevOps guys or pure operational guys are familiar to, and so you have the benefit 2 times. First, the general visualization as it is, also the manager and non-technical guys, and the second one, out of that point, you also might have this connectivity between, the real operational, like notifications and other things that triggering the fixing policies or procedures that the company has, and having them integrated between this visualizer and real, like as I said, New Relic or Insignia or something like that.
Which tools were you talking about at the start of your question?
Probably the main here there would be, well, let's take a New Relic as an example of the real operation monitoring tool, which collects the statistics and gives a notification to operation guys or first line support or product team if it's already
metrics, there. Like Prometheus kind of thing, I suppose.
So this dashboard that you have at the moment, is it possible? Is there any already hooks or APIs that could be used to integrate touch to tools like this dashboard that you just presented and New Relic?
Yeah, so like webhooks kind of stuff. Well, we don't have webhooks yet, but that would be a very good idea, I think, to put in there. The thing that's we are currently focusing on is just visualizing the links between, the static links between microservices and their components, not necessarily traffic. And traffic is something where you can get metrics from and where you can get alerting, that kind of stuff, like real-time operational stuff. I'm not sure if we should build that into our microservice dashboard right now. For the reactive efforts, that's probably going to be in there. But there are also some other tools that are already greatly, doing that much better. So having webhooks to show, for instance, alerts from the other applications in here and integrate them with these microservice bubbles where you can see which microservices have issues, that's something very valuable. So yes, I think we will work on that in the future. But currently, there's no API yet for that. But good idea. Yes?
Hello, thanks. This dashboard currently shows only states of the moment of the system. Do it support, or will it have support for history? Because it's very interesting to see how system evolves from this point of view.
Yeah. So right now you can see the future, but that's as in the analysts just or developers, they kind of create nodes and links between them. But that's a single view currently of what's coming up. So you can't see this is coming up. I mean, you can if you go into the nodes themselves, but you don't have a timeline where you can go forward and say, okay, in 1 month, what will it look like? You basically have this is coming up. You don't know yet when, but it's coming up, which in a sense should be already okay for now. But once we have a timeline to really be able to say, in 1 month we will be having this view, in 2 months we will have that view. You can also go backwards, and you'll be able to just store that, because we just store the information as well in a database, so we can just as well do that for the history. So that should be fine. And then you can see as well the evolution of your system. Okay. All right. One more question.
Hi, thank you for the presentation. I'm wondering if your dashboard addresses backward and forward compatibility of the contracts somehow between the services or microservices.
Backwards compatibility, or?
Yeah.
Well, I think the best we can do is to visualize contracts, what they explicitly mean, how they are defined, and which things are basically backwards breaking in the new version and which ones aren't. I think being a tolerant reader on the consumer side, it has a lot to do with that. With visualizing, I mean, across versions then, I suppose, right?
Yes. Sometimes you may want to introduce some breaking changes or replace one service with another, so it may be helpful to manage these kind of transformations from the perspective of dashboard to make it visual.
Well, we have consumer-driven contract testing for that, basically. So if you write these tests or these definitions as contracts, and then you have tests set up on the producer side, then that will give you this information. Having that in the dashboard, we can read this, but if you don't have contracts defined at all between client and producer, then client and server, then we won't have a source to read this. But if you have an idea, feel free to come after the talk as well, and we can talk about it. Okay. Thanks, everyone.